Okay, so we were discussing the properties of RSA algorithm. So as you know that in the RSA algorithm, so we are discussing that the RSA algorithm, it has a property, and this property is called that when a message M, it is encrypted with a public key of Bob, then this encrypted message can only be decrypted by using the private key of Bob. Okay, so if this encrypted message is decrypted using the private key of Bob, then it will again give you the plain text message. Similarly, so here the message is first encrypted using the public key, then this encrypted message is followed, can be decrypted by using the private key of Bob. Similarly, here the message M, it is encrypted using the private key of Bob, then this encrypted message, it can be only decrypted by using the public key of Bob. So when it is decrypted by using the public key of Bob, then it will give you message M. So this, as we have already discussed, that this is the property of public key algorithm, that if the message is encrypted with the public key, then it could be only decrypted by the private key of that user. Okay, so the result is same. So this is the mathematics, that how these private and public key are generated. So when these private and public key are generated, then this has the property, mathematical property. Okay, so it is a very good technique. Similarly, why this property holds, that if a message is encrypted with the public key of Bob, then it can be only decrypted with the private key of Bob. Similarly, if the message is encrypted using the private key of Bob, then it can be decrypted by using the public key of Bob. Why this property holds? So the reason is that when the key is generated, so it is done using the modular arithmetic, this algorithm, but you don't need to go into its detail, just you have to remember this property. Okay, now why is RSA algorithm secure? Why we say that it is secure? Okay, because there are the Bob, every user announces its public key to each and every one. Okay, so if a person has the Bob's public key, then how hard is it to determine D? That is, and it is very difficult to determine D, because the D, it depends upon the two factors P and Q, and these P and Q, they are unknown. So that's why it is very difficult to decrypt or to decrypt or to infer the private key of Bob using the public key of Bob. It is difficult, it is hard, it is impossible. Okay, now RSA algorithm, there are two aspects of RSA and this algorithm. RSA algorithm is a public key algorithm, and this is a private key algorithm. RSA is a public key algorithm, or it is a symmetric key algorithm. This is a symmetric key algorithm. Now, as we have discussed, that the advantage of RSA algorithm is that there is no need of secure key exchange in RSA algorithm. This is the advantage, but the disadvantage of RSA algorithm is that it is computationally intensive. It is computationally intensive. It takes longer time to encrypt and decrypt the message using RSA algorithm. Why? Because it uses modular arithmetic. It uses modular arithmetic, and it takes time. Okay. So therefore, the RSA algorithm disadvantage is that that the RSA algorithm is computationally intensive. But the advantage of RSA algorithm is that there is no need to secure exchange the key. Okay. The advantage of this algorithm, symmetric key encryption algorithm, is that it is 100 times faster than RSA. It is not computation intensive, so it is faster. But the disadvantage of this algorithm is that the DES algorithm, symmetric key algorithm, its disadvantage is that there is a need of secure key exchange. There is a need of secure key exchange, and that is difficult because there is no accountability, as we have discussed previously. Okay, so it means that both DES and RSA algorithm has its advantages and disadvantages. The RSA algorithm advantage is that there is no exchange of key, secure exchange key, and the DES algorithm advantage is that it is faster. The RSA algorithm disadvantage is that it is computationally intensive, it is slow, and the disadvantage is that there is need of secure key exchange, but it is faster. So basically, how to combine the best advantages of both DES and RSA. So actually both algorithms are used, RSA and DES, they are both used in combination. How they are used in combination? First, the user use public key cryptography to establish secure connection. So the public key algorithm, the RSA algorithm, is only used to establish secure connection. What does it mean? To exchange the symmetric session key. To exchange the symmetric session key. The symmetric session key which will be used by this algorithm. Okay. So this symmetric session key of the DES algorithm, it is securely exchanged between two users by using public key algorithm or by using RSA, because this is only involved in the first step, in the initial first two steps. After the symmetric session key is exchanged using RSA algorithm, using public key algorithm, then this symmetric session key is used for encryption and decryption the messages by using DES algorithm. So for the data encryption and decryption, the DES algorithm is used. So both, because for the establishing the secure connection or for exchanging the symmetric session key, it is only one or two messages. And then after, when the user are exchanging the data, for example 10 messages, 100 messages, 1000 messages, then for that data exchange they use the symmetric session key using the DES algorithm, encryption and decryption. Okay, so for example, this is the session key case. This key is used by DES algorithm for encrypting and decrypting messages. So the Bob and Alice, they use RSA, which is a public key algorithm, to exchange this key S, symmetric key S. When this key is exchanged between Bob and Alice, after this both Bob and Alice, they use this algorithm to encrypt and decrypt the message using the DES algorithm. Okay. Now after this, now we are going to discuss the chapter number another important property that is called message integrity. Okay, message integrity, but the message integrity involves two parts. One is called authentication and one is called the message should not be altered, to ensure that the message is not altered. Okay, so first let's discuss what is authentication. So before coming to the authentication protocol that is used in practice, let's discuss that how authentication protocol can be developed. So suppose Bob wants Alice to prove her identity. This is called authentication. Okay, so let's suppose we have a protocol that is called protocol A, authentication protocol 1.0, and in this protocol the Alice says I am Alice. So based on this I am Alice, the Bob can come to know that this message is from Alice. But you can see that when we talk to each other physically, we can see each other. Then we can identify, okay, this is Alice who is talking. But in the internet, the users, they cannot see each other. For example, when you are accessing the Gmail server, so the Gmail server doesn't see you, that you are Ali, you are Nadir, etc., you are Bob. They don't see it. So if someone else is trying to access the Gmail server and it pretends that it is Nadir, but it is not Nadir, it is someone else. So how Gmail server can come to know? So this is the failure of this protocol. This protocol is okay if both users, they can see each other, but in the internet it cannot work because it will fail. And what is the failure scenario? So let's discuss it. Suppose this is the failure scenario, that this is the Trudy, she sends a message, I am Alice. So since the Bob cannot see Trudy, so the Bob will assume that this is the Alice, but it is not Alice. So this is the failure. So this protocol cannot work. Protocol AP, authentication protocol 1.0, it cannot work in the internet because in the internet the user cannot see each other. Okay. So in the next video, next protocol is called protocol 2.0. In this protocol, suppose Alice says, so along with this message, I am Alice, the Alice also sends her IP address, and suppose her IP address is known to Bob. So when the Bob receives the message, I am Alice, so the Bob also look at the Alice IP address. Okay, so in this case the Bob can identify that, okay, this message is from the Alice. But this protocol can also be failed. How it can be failed in the internet? For example, we have a technique called spoofing, IP spoofing. IP spoofing means that Alice generates the message, I am Alice, and Alice can see the IP address of Alice. That this Trudy can generate a message, I am Alice, and this Trudy can also put the IP address of Alice, because when the Alice was talking with the Bob, so this message was seen by Trudy because it is going through the internet, so anyone can see it. So when the Trudy see this message, so the Trudy also record this message, I am Alice, and it also record the Alice IP address. Okay, later on this Trudy sends the message, I am Alice, and it puts the IP address of Alice in the message instead of her own address. Instead of Trudy IP address, the Trudy puts the Alice IP address, and it can be done. This is called IP spoofing. By using IP spoofing, you can do it. The PCAP library is used for this purpose. So in this case, the Bob will assume that this message is from the Alice, but this is not from the Alice. It is from the Trudy. Okay, so this is the failure scenario of protocol AP 2.0. Okay. Okay, now we are going to discuss in the next video the protocol AP 3.0. Okay.